We want to turn to a deeper dive right now on a breaking news story we've been following since the very start of it this morning. And it's coming to us out of Mooresville. In case you're just catching up on this headline, really terrible situation in that there was a tanker truck that exploded at Carolina Beverage Group in Mooresville this morning. One person died, another person was injured. We're still waiting to hear their specific condition. But essentially, when firefighters arrived, they say that this tanker truck had obvious explosive damage, and this truck was also carrying sodium hydroxide. As we mentioned before we went to break, we are hearing from officials that they feel like the situation is largely contained. They feel like there's not a danger to folks in the community, but we did want to learn more about this particular substance and what its potential impacts could be in general. And so right now we have Susan Richardson, who's joining us from University of South Carolina, and we appreciate all of your insights on chemistry, because we know we've spoken to you before in other stories, including the Silfab solar recent chemical incidents. So thanks so much for your time here and joining us once again.
You're welcome. Happy to help.
So we're talking about sodium hydroxide here. We mentioned this is happening at Carolina Beverage Group, so it's a beverage company of sorts. Are you able to share typical uses of sodium hydroxide? Why might the substance be there on a beverage site?
Yeah, so there are a couple of reasons. My first thought is to adjust the pH of the final beverage, right? pH is important. But also, I was reading today and I learned that they use sodium hydroxide a lot for sanitizing bottles and the equipment, all the pipes and the tanks and things like this. So it could be used for cleaning. Sodium hydroxide is a strong cleaner as well. And so one of the brewery sites I saw, I know this is non-alcoholic beverages here, but it says it destroys beer spoiling microbes and it will get rid of fats and grease. And so if that kind of stuff needs to be cleaned out of the bottles or the lines in the production plant, it can be used for that as well.
And I'm thinking back because, candidly, I loved chemistry when I took it in school. It's been admittedly a long time ago, but I remember in chemistry you learn about different substances and whether they're acids or they're they're bases, and whether you're on either side, acid or base. I feel like there are different concerns that you might have in the sense that, like, while we think, acid can burn skin, but base can burn skin too. I mean, in this case, sodium hydroxide, where does this fall on the spectrum of pH? And in that regard, what sort of impacts might there be because of it? Are there concerns with skin issues or breathing? What do you usually see as typical problems with sodium hydroxide?
And kudos that you remember some of your chemistry. I think that's great. So
It was one of my favorite topics.
oh, it's obviously one of my favorite ones too. And so just like people think about a strong acid, say like think you spilled battery acid or something like that on yourself, and you know you're going to have burns and things like that. Strong bases do exactly the same thing. So whether you've got on the low pH end with the acids or the high pH end with the bases, you're going to burn your skin. You can have severe, if you get it in your eyes, severe eye damage, could even go blind if you have too much of it in your eyes. It's corrosive. I mean, it's corrosive to everything. And even the aerosols from a big explosion, all of that liquid going out everywhere, if you breathe that in, can scar your lungs. It's very damaging. So I looked up to see what, level, what molarity or percent level might be used in this process. And it was saying it's typically 1 to 4% of sodium hydroxide. And that pH would be 13.7 to 13.8, really high.
Wow.
The highest we could go is 14 on the pH scale. So that's the equivalent of having a pH 1 really strong acid. It's just the opposite end of the pH scale, but does the same kind of bad things. Very, very strong.
Yeah. The other question I guess I have about this is we know that the other element of the story was that there was some sort of explosion. And while we know the tanker truck had sodium hydroxide on it, is it possible to deduce whether the sodium hydroxide caused the explosion or if it's just, a situation where it happened to be on the truck and maybe something else happened that caused the explosion? Does this thing explode, I guess? Does this substance explode?
Right. Do you happen to know? I assume that it was carrying sodium hydroxide inside the tanker. Do you know that?
This is what we have basically from officials, that a tanker truck with sodium hydroxide exploded. Firefighters arrived. They say that there was obvious explosive damage, and I'm trying to see here. They identified a spilled chemical on scene as sodium hydroxide. And then this sounds like this might be unrelated, but there was a secondary leak at a stationary nitrogen tank, which was then contained. But it sounds like, just kind of reading between the lines, that they're calling this secondary, so it might not have really just been involved with the actual explosion. It just was something they saw afterwards that was an issue to be addressed.
Okay. So I guess let's assume that it sounds like it was probably carrying the sodium hydroxide in the tanker truck. So when I was reading today, there's some metals that can be reactive with sodium hydroxide because sodium hydroxide is extremely corrosive. So if it's the wrong kind of tank, and apparently aluminum tanks are not supposed to carry sodium hydroxide because it can corrode aluminum. Zinc is in that same category. Brass, tin are in that same category. And so let's say that the sodium hydroxide was corroding that aluminum tank or piping that's made of aluminum. That can react to cause an explosion. So the two things, the sodium hydroxide plus the aluminum plus a little bit of water, and what happens is that causes the formation of hydrogen gas. So H2 gas that right, hydrogen can explode, and static electricity or friction or some kind of open flame, situation could have caused that to go off. So there could have been a hydrogen bubble build up inside that tanker truck, potentially. I don't know that that's what happened, but that's potentially what could have happened. And also just heat itself, could cause pressure of the sodium hydroxide in the tank. But I know it hasn't been terribly hot outside lately, right? So I don't know. But if that tanker truck had overheated for some reason, let's say there was an engine issue, it's overheating, then the buildup of gas in that tank could have also caused an explosion.
Yeah, I appreciate you kind of looking through some of the theoreticals, because I guess, as we pointed out, this is still under investigation, but it is interesting to think about some of the potentials here in this case. And I know it feels like maybe for some of our viewers, like we're going into the weeds here. I feel like this does maybe bring up a more everyday application, if you will, in that, you pointed out how it could be potentially problematic to have sodium hydroxide carried in certain types of containers. For example, you mentioned aluminum. I think that there are a lot of everyday chemicals that folks might have in their home that they're not thinking about, either how am I storing these, what sort of chemicals am I layering on top of each other? And I just think about, some of the cautionary tales I hear about, for example, when you're cleaning your bathroom, you don't want to mix certain types of cleaners because that can actually make, basically like gas that can burn your lungs. What sort of, I guess, suggestions would you make to folks just on an everyday basis of, general chemicals that they might have in the home, and how can they best either do research or look into like best ways to keep themselves safe when they're dealing with these, household chemicals?
Yeah, and there are a lot of different household chemicals, right? You mentioned some, and even the sodium hydroxide is also known as lye. So lye soap, that's what sodium hydroxide is, essentially a different form. But just, the warning labels, all those different products will give some warning label like don't mix with this or don't store in a certain kind of container. A lot of strong acids, for example, I've used muriatic acid before for cleaning something in the way past, and it comes in a heavy glass bottle, for example. You wouldn't want to store, that acid, strong acid or strong base in a metal container, for example, that's going to corrode, So they need to be stored in the right kinds of containers and not mixed with certain other chemicals. And usually there'll be warnings on those cleaner bottles, don't mix with XYZ. So just pay attention to that before you go mixing anything.
Yeah. And interesting, I hadn't made the connection between sodium hydroxide and lye, but we've heard various stories of how folks maybe with dubious purposes have used lye to try to dispose of certain things just because it can eat up so quickly and so efficiently through various substances, if you will. So thank you.